Hi, this is Miss Park. Today's video is about transformations, special kind of transformations called translations. So we've already seen in class with Desmos what happens when we add things to parents. So this little table kind of summarizes what we did in class already. If you have a function f of x and we add a number to the end of it after the f of x, then the result is a vertical translation. It's a shift either up or down depending on the value of k. And here it tells you what we summarized in class. If the extra number is in the inside of the bracket, then that creates a horizontal translation, so movement from side to side, left to right. So the reason this happens is because when we have our f of x, we have suppose we were making a table of values, we have all our x's and all our y's, and what we're doing is we're actually adding this number to every y value. So without changing any x's, we are changing y values by adding this number to it. Now, if we look at this one we are not changing the output like we did here, we're changing the input. So imagine keeping all of the y's the same. What would happen to the x's so that this input produces the same y's as before? So remembering the function machine, here's your function machine, your x is your input, your f of x or your y is your output. Okay, so whether we're changing the output or the input, that's going to affect what the transformation is. Okay, so now I'm going to take you through, we saw it in Desmos, but I'm going to take you through how we're going to graph functions by hand. Okay, so there's a few steps and they're all really important, so please don't skip through this. Okay, so just go through all the small details. Let's start with our plain old vanilla quadratic. Okay, and this is saying to sketch and determine each of the following. Sketch, we know what it means. Sketch means to sketch it on this grid. Determine means write the equation of f of x plus 2 or whatever. So let's start with, I would like to start with b. It's a little bit easier. So let's start with b. F of x and then the 2 is outside. So what I'm going to do is I'm going to start by, on the side here, just draw our basic vanilla quadratic. So we can always use these points, -2, -1, 0, 1, 2. So for our purposes in this class, these points are sufficient. And you figure out x squared, so that's 4, 1, 0, 1, 4. Okay, so I'm going to sketch this here. So we're very familiar with this one already. 2, 4, 2, 4. Okay, and then I got this. Okay, and I'm going to label it y equals x squared. Now I'm going to change pen color and work on f of x plus 2, this one here. So what has happened when we add a plus 2 to the end of the f of x's, what we're going to do is we're going to end up adding 2 to each number in this column. So instead of having the point -2, 4, I'll have the point -2, 6, and -1, 3, and 0, 2. Okay, we're adding 2 to the end. So first thing we're going to do when we graph is we're going to describe the transformation in words. So the transformation is that there is a translation 2 units up. And we're going to be using this language. So there's a translation 2 units up. And then we're going to do something called a mapping rule. The mapping rule is something that tells us what's going to happen to each point. So each point xy that used to be in our parent, what's it going to look like now? So mapping rule means I'm going to take something and kind of change it and it becomes something else. When we translate up, what happens to the x coordinates? When we translate this entire thing up, what happens to the x coordinates? So nothing, right? They stay the same. What happens to the y's is that each y, we're going to add 2 to it. Okay, and that is called a mapping rule. So I'm just going to write for you here. This is called a mapping rule. So for every transformation, for every question we're going to do from now on, we're going to always write the transformations in words, and then we're going to write the mapping rule. And then what we're going to do is we're going to take each point from the parent and transform it according to the mapping rule. Now, this is a very simple one, but remember, we're just starting this, right? There's lots of transformations coming. So the x's will stay the same, but the y will be +2. So -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. Okay, so now I can put the points on. -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. Okay, and there's my transformed one. The next thing it said is, so I sketched it, but it says determine. So now I want to find the equation of this. So I'm just doing it down here. So it's y equals f of x plus 2, but what was f of x? It was x squared. So then it's just +2. So now when I label this, I actually have an equation for it. Y equals x squared plus 2. All right, I'm going to change pens. We'll do this one here. So we know that we are changing the input, and so we're going to have a horizontal translation. So what is the translation? Let's see what happens. Because I'm changing the input, I'm leaving the output the same. So to get the output the same, what has to be true about this input? So if x plus 2 becomes my input and I want the output to be the same, that means that x plus 2 must equal these values. These are the values that are going to give this output. So if x plus 2 equals -2, that means x would have to be -4. And if x plus 2 is -1, that means x has to be -3. And if x plus 2 is 0, that means x has to be -2. So what's happening with this transformation is our x's, in order for x plus 2 to equal these values, our x's are going to have to be 2 units smaller, so that when we add 2, we're going to get this table, which produces these y's. So the result of that is a translation to the left. So I'm going to write here, it's a translation 2 units left. Okay, each of those x values, when you add 2 to them, should give us these x values because that's what's going to produce these y's. So now I'm going to write the mapping rule. What does that mean? So xy, the y's are going to stay the same because I haven't changed anything over here, but the x's are going to be 2 less than what they were. And that's what's going to give us our shift to the left. So this is our mapping rule. And so now I can take these points and transform the points. And so I'm going to be subtracting 2 from every x. So I'm going to get -4, but the y is the same. -3, 1, -2, 0, -1, 1, 0, 4. Okay, and so now I'm going to put them on. So -4, 4 is here, -3, 1, -2, 0, -1, 1, and 0, 4. And now I have this green one here. Okay, let's write the equation of it. F of x plus 2. So that means I'm going to take I don't have much room, but I'll stick it on the side here. It means I'm going to take my x plus 2 and make it the input into the function. So I'm replacing x with x plus 2. And that is my new equation. I could expand it and put it in factored form, but there's really no need because it doesn't say we need to. So we can just leave it like that. And you'll notice that this is actually vertex form. These equations are vertex form. The first one is, you can see the vertex is 0, 0. Remember vertex form, y equals a x minus h squared plus k. If you don't see an h and you don't see a k, the vertex is 0, 0. This one here, the vertex is 0, 2. And this one here, the vertex is negative 2, 0. All right, so that was the parabola that we know very well. Let's do the same thing with some of our new functions here. So let's do the radical. All right. I'm going to put the table of values here again. So x, y. So we could use, we know that the radical function is not defined when x is negative. So we can just use positive numbers. And I'm going to use the ones that are perfect squares so that I have nice whole numbers for our points. So 0, 0, 1, 1. Sorry, I'm off a little bit. 0, 0, 1, 1, 4, 2, 9, 3. Okay, and this is y equals square root of x. Right? Okay, and so that one's done. Change pens. F of x minus 2, so that's going to be a translation 2 units down. And so now I have xy, my mapping rule. Xy will become, so if I'm going down, my x's won't change, but my y's will be reduced by 2. Take your table of values. So it's really important to know the table of values for that parent because it gives us the ability to do things to it. So x's will stay the same, but y's will be reduced by 2. So here are my points: 0, negative 2, 1, negative 1, 4, 0, oops, yeah, 4, 0, and 9, 1. All right, what's the equation? So y equals, so f of x is just the square root of x, and then I have a minus 2 on the end, so that's it. All right, change pens. This one here, I have plus 3 on the inside. That's kind of like that plus 2 that we had. So when you see that plus, that means, let me just go up to the table. It should be a minus. It's kind of like the vertex form formula. It should be a minus. So if you see a plus in here, it means this h number is negative. So it is movement to the left. All right, so I'm going to write the transformation in words. So translation, 3 units left. Okay, a full solution will always, always include the words for us. Okay, so get used to this words, they're not going away. Okay, and then let's take our table and transform. And this is how we graph by hand. So negative 3, 0, negative 2, 1, 1, 2, 6, 3. So I'm going to put them on. Negative 3, 0, negative 2, 1, 1, 2, and 6, 3. Okay, kind of, sort of. All right, and what is the equation? So look where our x plus 3 is. It's the input to the f of x. So the input becomes x plus 3. And so that is our equation. All right, one more, which is the reciprocal. So let me go to it on the next page. And this is the last one we're going to do. So the idea is exactly the same, but you need to know your parent. So please watch this, how we're going to sketch our parent. It's a little bit different than the others. If you flip back to that very first page in our booklet, when we learned about the parents, you can see that the table of values has all these complicated fractions, right? The thing is that we can't really graph these things properly. They're going to be estimates. So I'm going to show you an easier way to graph reciprocal functions that's not going to use all of these fractions. But don't forget, reciprocal functions have asymptotes, so we're always going to include asymptotes as part of our graph. So I'll show you how to get around this mess here, but very important to still be including asymptotes. So because all of those fractional points are hard to graph, they'll be estimates anyway. We're going to use for this one 2 anchor points. And the anchor points are the points 1, 1 and -1, -1. I just should have done it the other way, put the -1 first. Okay, if you look in the table, you see the only points that don't have fractions are this -1, -1, and 1, 1. And at 0, of course, it's undefined. Everything else has fractions, so they're hard to draw. Okay, so I'm going to use these 2 points. And I'm going to make sure I don't forget to draw the asymptote. So let's put the parent. The parent's going to have asymptotes at y = 0. So asymptotes are always drawn with a dashed line like this. So this is, sorry, x = 0. And I'll draw another one like that. So this is a dashed line. And your graph of reciprocal is not complete unless it also has asymptotes. Now I'm going to put the point 1, 1. And what I'm going to do, I'm just going to hug those asymptotes. I'm going to try to draw it curvy as much as possible, getting close to those asymptotes but not touching. Same thing with -1, -1. I'm going to hug the asymptotes. Love those asymptotes. Okay, just hug them, come close, get to the edge of the curve or the edge of the grid as close as you can. All right, and so this is the graph y = 1 over x. All right, I'm going to now switch color. We'll do the vertical one first. So this is a vertical translation. So we say translation 1 unit up. The mapping rule looks like xy becomes, so when you're going up, the x's don't change, but the y is +1. We're only using these 2 anchor points. Okay, so 1, 1 becomes 1, 2, and -1, -1 becomes -1, 0. So I'm going to have a point at 1, 2, and -1, -1 becomes -1, 0. So these are my 2 points. But what else happens? When the entire graph shifts up or down, so do the asymptotes, right? Now, the vertical asymptote, which is x = 0, is not changing because our x's are not changing. But our horizontal asymptote, which is y = 0, is going to go up with the rest of the graph and become the line y = 1. Okay, so this is the line y = 1. The asymptote for this graph is still x = 0. I'm going to draw it again over just so to show it with a different color. So now you can see these brand new asymptotes that are in pink, and all I have to do to graph is to just hug them. Just come really, really close to them. And there's one here. So it's a little hard because I've got like so many graphs on the same little grid. You'll get used to it. And so this is, so now let's write the equation. So now I'm just going to write over here that the asymptotes have changed. So what are the asymptotes? It's still x = 0, but it's also y = 1. Okay, and that's the whole transformation. Now all we need to do is figure out the equation. So f of x is 1 over x, and all I'm doing is I'm adding a 1 on the end. So y = 1 over x plus 1. Okay, and finally, f of x minus 3. We see a minus there. That means this think about like vertex form. This movement to the right is 3, so it's a positive 3, so I know that I'm moving to the right. If that was a plus, then it would be a -3, means I'm moving to the left. Okay, so I'm going to write that out. So it's a translation 3 units right. Now moving to the right means my x's are going to be 3 bigger. So x plus 3, y, right? Moving to the right means my numbers are getting bigger. So I only have my 2 anchor points. So 1, 1, it becomes 4, 1. Negative 1, negative 1 becomes 0, negative 1. Okay, and so let's put them on. So 4, 1 is here, and 0, negative 1 is here. What happens to my asymptote? Well, the y's haven't changed. So this asymptote is still here, y equals 0. So I'm just going to draw on top in green. Remember, it's dashed line, y equals 0. But the entire graph has moved to the right by 3 units. So this vertical asymptote, 1, 2, 3 units, now becomes x equals 3. All right, and I can just hug the graph. And sorry, my point was 0, negative, yeah, that's right. Oh, something's off. Oh, 0, 1. No, I don't, why is it negative? Hold on one second. Sorry, messed up. 2, negative 1, of course. So 2, negative 1. Okay, so now let's draw this one. I know it kind of looks straight, but try to make it curvy. I know it's a little hard. This grid is really small. Okay, and so our asymptotes, let's write this here. So the horizontal asymptote hasn't changed, but my vertical asymptote has changed. All right, the last thing I have to do is write the equation. So f of x minus 3 is just going to be taking x minus 3 and putting it in for x. So that's just 1 over x minus 3. So find an arrowhead somewhere, and we'll just label this. This is y equals 1 over x minus 3. Okay, and that's translations. That's how we're going to do them by hand. So just recap of the steps, always the words, okay, words, then mapping rule, map the points, if there's asymptotes, and then the equation. Okay, so that's going to be our process. Thank you for watching.